we talked about yesterday. So you can see the relationship of why we are doing these things together. So, definition, an nth root for any real numbers a and b and any positive integer n, if a to the n equals b, then a is the nth root of b. So what this is saying is 2 to the 6 is 64. You do 2 times 2 times 2 times 2 times 2, it's 64. So 2, and you should say is the 6th root of 64, which also can be expressed as the 6th root of 64. So all they did here is they solved this. They just said, to undo something that's squared, you take the square root. To undo something that's squared, you take the square root. Do you guys agree with that? So to undo something that's to the raised to the 6th power, you take the 6th root, and that takes that off there, so you're left with 2 equals the 6th root of 64. So that's where that came from there. So an nth root just means a, radical there. And we talked about nth roots yesterday. We talked about square roots, cube roots, fourth roots yesterday. We might have done a fifth root. Okay, so index. So we have to talk about indexes being even and odd. We have to talk about indexes being even and odd. So if your index is odd, then if there's a negative radicand, then the final answer is negative. If the radicand is positive, your answer is positive. So think about this. The cube root of negative 8 versus the square root of negative 4. So this is an odd radicand, an odd index, and this is an even index because our index is 2 when nothing is there, right? If you have an odd, you're saying what number multiplied 3 times gets you negative 8? What number multiplied 3 times gets us negative 8? Well, 2 times 4, 2 times 2. So this is 2 times 2 times 2. We're looking for groups of
3.
We have a group of 3. Everything's circle, so we don't have a radicand anymore. But we know that 2 times 2 times 2 is not 8. What could we make that 2? Is negative 2 times negative 2 times negative 2 negative 8?
No, it's 8. No,
Negative 2 times negative 2 is positive.
Yeah.
4, a positive and a negative is a. So, if it's a negative under an odd radical, it's going to come out with a negative answer. The problem here is, with this one, the same number times the same number is a perfect square. So typically, we would say the answer to this is 2. But 2 times 2 is not a negative 4. Is negative 2 times negative 2 a negative 4? No. Is there any way to make a negative number by multiplying the same number times the same number?
No.
No, because one's going to have to be negative and one's going to have to be positive. So in this case, this is an imaginary solution, and you'll learn more about that in Algebra 2. So if the index is even, you have an imaginary solution if your number is negative. So just a few things to think about here before we move on with what we're doing today. So go ahead and flip to the next slide. I'm going to skip that next slide because we went over homework together already. So we can get to the other notes.
Wait, we have more notes?
I've already said this. It's not the first time I've said this.
2, 1.
So we're having 2 sheets of homework?
Oh my gosh, no. The homework will be handed to you tomorrow for the lesson, the second lesson. Okay. A fractional power is really just a root. So the nth root of x to the m is the same thing as x to the m over n. So you'll notice here, this is the index, this is the exponent. This switches to a rational exponent by doing the exponent over the index. A rational exponent, a fractional exponent, is really just a root. Or you can think of it this way. X is being raised to the numerator over denominator, right? A fractional exponent. That means that if you change it to a radical, it's denominator as the index. That goes right there. and then it's x to the numerator. So we are going to just be switching back and forth between these for a little bit and simplifying if they're numbers. We'll talk about that in a second, though. So first of all, the cube root of 8 is just 8 to the 1/3. Well, we know that the cube root of 8, if we do the factor tree, is 4 times 2, which is 2 times 2. 2 times 2 times 2. We're looking for groups of 3, so that's why this is 2. Do you guys see that? What is the index if there's no index outside?
2.
So this is a 2, and there's an exponent of 1. So you do the exponent over the index, so it's x to the 1 over 2. These already have it there, so it's exponent over index, so it's x to the 2 over 3. This here, be careful with this one, is x squared, so it's x to the 2/3, which is 4. So this is what I would have you do with these ones. I would have you square the 8 first. 8 times 8 is 64, and then do the factor tree. So look at this here. We're looking for groups of 3, and I have 2 sets of groups of 3 twos. Do you guys see that?
Yeah.
So this becomes 2 times 2, which is 4. You weren't here yesterday, so that's why you're confused. All right. So we're going to now do the next 2 slides together, and then we're going to move on to the next notes. So the next 2 slides together. You are not anywhere even near where I'm at. I'm right here. I just wrote a ton, and you didn't do any of that. You've got to be paying attention. Okay. So convert to radical form and evaluate if possible. Evaluate means find the answer. So this means find the answer. So first of all, if we think about this, remember what I said. It's x to the numerator over denominator goes to the index being the denominator, x to the numerator. Do you guys see that? Okay. So, Emma, how would you rewrite 16 to the 1/4 power? You're fine. Look at this. It's x to the numerator over denominator. The denominator becomes the index. So what's my index? No, just one piece of that. So this is my index, and this is my exponent. So I have the 4th root of 16 to the 1st. Well, anything to the 1st power is just itself. So now we can evaluate this because it's a number. 4 times 4 is 2 times 2 is?
No 4.
So I list out my 2 times 2 times 2 times 2. I'm looking for groups of?
4.
Do I have anything left over under a radical?
Perfect score.
It's a perfect 4th.
4, whatever.
But yes, and what is the perfect 4th of that?
16.
4th root of 16 is 2. You take 1 out of the circle. Okay, RC, how would I rewrite z to the 1/5 then? What would be my index, the 1 or the 5?
Oh,
The denominator goes to the index spot. So which one is your index? So this is the index, and this is the exponent. So it is the 5th root of what? Of what? Of z, right, because it'd be z to the 1st power. Stop it. Lexi, seriously. Stop. So that is your answer. We can't evaluate just a single z. Do you want to try it, Colin? What would it be?
Okay, so I think it's
So you've got like the square root thing. It's 4.
The fourth root.
Fourth root.
I'm just
And
going to
then-
help you guys because you're not used to this yet.
And then with the a on the inside, and then to the first power.
Yep, and I'm not going to put the first there because it doesn't matter. Okay, no, stop that. I'm going to move you if you're going to do that.
No.
Justin Powers, how do I do number 4?
Two's gonna be on the outside.
Do we put a 2 on the outside?
Yeah.
Nope, we don't put a 2 when it's there. We leave it blank. Remember, when it's 2, it's blank. So it's the square root of to the, but we don't need to worry about the first. So we do 3 times 3. We look for groups of, because the index is not there. So what's the square root of 9?
3.
You know, you could just like do this in your calculator.
If there's a variable, you can't do it in your calculator, so good luck. Emma.
It's still like, if you get a perfect circle, you still just take one out.
You always take 1 out of a circle. You just wouldn't have a radical anymore if there's no more circles.
Okay.
Okay, Mike, how do I rewrite 5 to the 1/3?
So, take the little thing and then put the 5 inside, and then on the outside, is 3,
So it's a cube root, good.
and then the inside is 1, but so it's nothing.
So it's 5 to the first. Can you do a factor tree for 5?
No.
No, so is there any way to simplify this? Already simplified, you are right.
You not use like half numbers.
You have to use whole numbers. Okay, Jordan, Wilds, how do I rewrite 81 to the 1/4? So it's the radic and it's in the inside, good.
And then on the outside would be 4.
So the index is 4, so this is a 4th root. Okay, anything else?
No, because the exponent is 1.
Right, this would be an exponent of 1, which we don't need there. Okay, so can we do a factor tree for 81?
Yes. Yes. 9 and 9 and then 3 and 3 and 3 and 3.
It's okay.
Spoil it.
I'm looking for groups of... I'm looking for a group of 4. It's a perfect... I don't know what I was trying to put together there, but whatever. It's a perfect 4th, as you said, and it's the perfect 4th of 81 is... Okay, do we have questions going from a rational exponent to a radical before we do the next ones? Only one? That's good. Okay, so now we're going to make it a rational exponent. So, this is to the first power. Notice this one does not say to evaluate. We're just going to leave it. So, Jack, how would you rewrite the cube root of 15? It is 15 to the 1/3 power. No, like, we'll do number 2, so it won't. Look at number 2. Tanari, what is number 2? A to the 3/4. So do you see if there's an exponent that's in the numerator? Jayla, what is number 3? There's an exponent of 1, so it's 2 to the 1/5. Very good, guys. Connor Clover, number 4. You guys are doing awesome. Lexi, number 6.
X to the... Wait, that's number 5.
Number 5.
Okay. X to the 1/4.
Whatever I'm trying to say. Did anybody figure out how to do number 6?
I did it.
What do you think it is?
I think X to the 7th, 8th, and then Y. I don't know how to say it.
Y to the 8.
Y to
1 8.
Yep.
Y to the-
Each one of these needs to have 8 as its denominator.
It's just like, I got close.
That's okay. I said perfect, so we're all good here.
I like that word.
Okay, Blaine, how do I do number 7? To the... What's the exponent here if there's no exponent? Okay, so it's y to the 1 over 2 because our exponent is 1. Okay, Cassie, do number 8 based on number 6.
I need to go home.
A to the 1. 3 over 3.
Which is just, so we have a to the 1/3 b. All right, so that is, we're not going to do the try these. That is lesson